everybody. Welcome to Bitcoin Faculty. I hope the day is treating you well so far, wherever you may be. Today, we are continuing our learning of Bitcoin analysis, but more importantly, at this stage, we are looking at the fundamentals in Python. We've already made some important discoveries just by covering the fundamentals, such as hexadecimals and the use case of hexadecimals in Python. I will actually be posting a video tomorrow, which basically sums it up in about 20 minutes, everything that we learned so far there. Let's head over to our learning page. So we are here on learnpython.org. We've already covered hello world, variables and types, lists, basic operators, string formatting, and basic string operations. So you can see we're actually already about halfway through the basics. And yeah, at that stage, I would say we have a good foundation to then proceed to the next stages of learning more about Bitcoin and what's happening with Bitcoin under the hood. So today we're going to start with conditions. I will put in 10-minute breaks as we go along. I know that it helps. It can be a lot of information to absorb, and I also appreciate that you are also busy and you might not be able to do this all in one go. I'm just going to refresh that. I'm just going to open a new tab. Conditions. For some reason, it gets stuck if I'm on the website too long. It's not loading the code. Conditions. There we go. Okay. Python uses Boolean logic to evaluate conditions. The Boolean values true and false are returned when an expression is compared or evaluated. So for example here, we've declared a variable x and we've assigned it the number value 2. Remember, when we're looking at variables, we're looking at two types, numbers or strings. In this case, it is the number 2. So it's asking us to print x equal 2. So it should print out true because x is 2. On the second example, it will print false because x is not equal to 3. On the next example, it's saying that x is smaller than 3. That is true, and so it should print out true. To put this in context, what the true-false Boolean logic allows us to do in programming is to make the code basically do things. If a certain condition is met, then something happens. So think of like your websites, how that would work. If you want the computer to do something or the program to do something, then you would use Boolean logic. So I'm going to run the code, and it printed true, false, true, which is correct. Notice that variable assignment is done using a single equals operator, whereas comparison between two variables is done using the double equals operator. The not equals operator is marked as exclamation mark equal. So if we change this to, for example, the first example, which is x equal 2, if we put in exclamation mark equal 2, in other words, we're trying to say print x is not equal to 2, it will give us false. Yeah, so it gave us false, false, false. I'd like to find out, I'm not really clear, why we are using sometimes 2 equals and sometimes 1. I think it's just because I'm confusing Python with JavaScript, where you have the strict equality operator. So it says in the note that variable assignment is done using a singles equal operator. And then when we're comparing, we use 2 equals. I'm just going to clarify with ChatGPT. This is for Python in JavaScript. The double equals operator means the strict equality operator. Is Python different in this respect? Okay, so it's just clarifying what I've said. In Python, the double equals operator is used for equality comparison, meaning it checks whether the values of two variables are equal, whereas the single equals operator is used for variable assignment. In JavaScript, the situation is slightly different. The single equals operator is also used for assignment, and the double equals operator checks for equality but performs type coercion, meaning it will attempt to convert the variables to the same type before making the comparison. So, because remember we get different variable types, so in JavaScript they use that as a safety measure to make sure that it's the same, not only the same, like as in it looks the same, but the type is the same. Boolean operators. The and or Boolean operators allow building complex Boolean expressions. For example, we've created a variable here called name. We've assigned it the value, which is a string, John. We've also created a variable age, and we've assigned it the value 23. So the if statement, and think of a condition, if this happens, then, because we're doing conditions. So if name equals John and age equals 3, then if those two conditions are true, because we're using and, so they must both be true, then it will print your name is John and you are also 23 years old. In the second example, which is using or, not and, it says if name equals John or name equals rec. Print your name is either John or Rick. So what happens with the or operator is that only one of them has to be true in order for this statement to print out. So let's run the code. Because name equals John and age is 23, it has printed out your name is John and you are also 23 years old. It's also because name is John, even though the name is not Rick, because John is true, it's also printed out the statement your name is either John or Rick. So let's see what happens to our AND operator if we change the age to 30. Then you can see it didn't print the statement because both the variables didn't turn out to be true because age is not equal 23. I'd like to do a little experiment here, or let's call it revision. Remember we learned in string formatting that we can actually bring in the variable in here because sometimes the name might change. This could become, for example, Christina. And then imagine having to keep going to each string like this and having to change it manually. So if we use our string formatting, so we would put %s, because remember it's a string, and you are also, and if I'm not mistaken, it would be %d. Then don't forget here, we just need to re-add our percentage sign, and then in our tuple, we're going to tell it what variables it must insert. So run, and it didn't work. If name unsupported operand type is for percentage, none type, and tuple. So there's obviously something we did wrong here. File line 4 in module. Yeah, it's line 4. Name, age. None type, tuple. We can go back and quickly revise that. So string formatting. Let's look at our %s. Okay, I think I see what we did wrong. It was our syntax that was incorrect because it wasn't in the brackets towards the end. So let's go back to conditions. And this time we will put in our brackets. So I've taken out the bracket at the end, percentage. We're going to say name, age. We're going to change John to %s to insert the string. We're going to change 23 to %d to insert the number. Don't forget it's double brackets at the end. And now it worked. Now we can change this variable, ignoring the if statement for now. Now all you would have to do is change it once here, and this is the cleaner way of doing code, rather than having to manually change your string. which practically you might have to end up doing multiple times. The great thing about variables is you only have to assign them once. So if the value then changes in the variable, if you do your code right, like in this case, we're formatting our string, then you don't have to worry, your string will just adapt automatically. The in operator. The in operator could be used to check if a specified object exists within an iterable object container, such as a list. So we've got here the variable name. We've assigned it the string John. If name in, and then we've created a list, because remember it's the square brackets. The list contains two strings, John and Rick. We've separated them by a comma. Then it will print your name is either John or Rick. So let's run. So basically what it's going to do, it's going to check if name, which is here, remember we've assigned the variable here, we've assigned it the value John. If John is in the list here, if name in this list, then it will print, then it will be true. Otherwise, it will be false. So let's just read that again. The in operator could be used to check if a specified object exists within an iterable object container, such as a list. Okay, so it's checking if that variable is in the list. So if we run it, it should print your name is either John or Rick. If we now change John, let's change it to Christina, then we won't get a print because John is not in the list. So you can see it's not printing anything. Python uses indentation to define code blocks instead of brackets. The standard Python indentation is 4 spaces, although tabs and any other space size will work as long as it is consistent. Notice that code blocks do not need any termination. Here's an example for Python's if statement using code blocks. So already we could see here, we can see how it's indented. So that we have the if, and this becomes a block of code, and then the print is indented. And then you see that this does the same thing. So in JavaScript, we use if I recall correctly, the curly brackets. In Python, we just use normal indentation. So let's have a look at this statement. And I'll explain to you what elif means. So we've created statement as a variable and we said false. Then we've created another variable. It's called another statement. Notice the underscore, the syntax that we're using there. You won't get an error if you don't use the underscore, but when we write in Python, that's the standard method of writing. So statement, we're saying it's false. Another statement, we're saying true. So if statement, as in this variable that we defined here, is true, this hashtag is just a comment, pass. I presume that means, I don't know what pass is. Okay. If this isn't true, ignoring what this pass means, right? If it isn't true, which is correct, its statement is actually false. elif basically allows you to create a list of conditions. And then when you get to your last condition, meaning if none of these are true, and you can keep adding elifs. If none of those are true, then you say else. And then you say in the end, what must it do if none of those are true? So let's run the code and see what happens. Just see what's going on here. It seems to be stuck. Restart. Run. Is it because it's pass? If statement is true, then pass. Otherwise, let's just adapt this. Let's try and make the if and the aleph false. In other words, it won't do these two actions. Let's say if another statement is false, because at the moment it's true. Okay, do something. Or else, what I wanted to do is print none are true. So that's what it's done. None are true. So the code ran through the first if statement. It was false. So it went to elif. It was also false because another statement is true, not false. And so the end result in that case is to print none are true. And then I'm just going to get clarity. I presume pass just means nothing, but let's just check with ChatGPT. Can you explain to me what pass is in this line of code? And I'll just say it. Seems to be stuck, so I'm just going to copy this and refresh. Come on. Okay, Control V, enter. You can also use ARIA, I suppose. In Python, the pass statement is a null operation. It is used when a statement is required syntactically, but you do not want to execute any code. It is often used as a placeholder where code will eventually be written or as a stub when working on a new piece of code. In the code snippet you provided, when the if statement is true, meaning statement is true, the code under if is executed. In this case, there is a pass statement, so no action is taken. If the elif statement is, which is basically meaning another statement is false, the code under elif is executed. Again, there is a past statement, so no action is taken. If neither the if nor elif conditions are met, the else block is executed and none are true is printed to the console. So in this specific code, the past statement is just a placeholder indicating that no action should be taken in those specific conditions. So I would just like to make a note of that here. So pass is basically, it means no action, and it can serve as a placeholder. So that's why initially when we ran the code, nothing actually happened because they all had pass. Then we have another example here. We have defined the variable x, the number 2. If x equals 2, print x equals 2. Else, print x does not equal to 2. So x does equal 2, so it will print the first option, the if statement, because the if is true. If the if is not true, see here it said x equals 2. If the if is not true, then it will print the else statement. So let's change x to 3, and we should get the answer now that x does not equal to 2. And that is exactly what we get. X does not equal to 2. A statement is evaluated as true if one of the following is correct. The true Boolean variable is given or calculated using an expression such as an arithmetic comparison. An object which is not considered empty is passed. Here are some examples for objects which are considered as empty. 1. An empty string. 2. An empty list. 3. The number 0. The number 0. 4. The false Boolean variable. I'm going to ask ChatGPT just to explain that, or let's use Aria to explain it to us in simple terms. Can you explain this to us in simple terms? Okay. In simple terms, a statement is considered true in Python if it meets one of the following conditions. So one is that the value is explicitly true. So this can be the case like now in the examples we've seen, or by using an arithmetic comparison. For example, they say here, for example, 5 bigger than 3. It can also be considered true, or it will be considered true, if you use an empty string or an empty list. If you assign it, I suppose, the number 0, or the Boolean variable false. A statement is considered true. So in Python, when checking if a statement is true, you can use these rules to understand what values will be evaluated as true or false. Sorry, so I misread that. So it has to be explicitly true. Okay. And then just things that we need to keep in mind with code is that by default, an empty string, an empty list, a 0, and obviously the value false, if you get that, are not deemed to be true. I will give some notes towards the end of this section on that. So let me just show you an example. So if we, instead of making x 3, we just put in an empty string. Now we know from our rules that that x now, according to Python, becomes false. That means it won't print the if statement that x equals 2. It will print the else statement. And that's what it did. X does not equal to 2. It's the same if we put in an empty list. So remember, we define a list using square brackets, and at the moment it's empty, so it will also be false. And then, of course, if we put in 0, we know that that will be false. And then if we assign it the value false, or the result could be false. Run, x does not equal 2. Remember, false can be something that we determine within an if-elif statement. It returns the Boolean value false. So remember those 4 things. Okay, the is operator. Unlike the double equals operator, the is operator does not match the values of the variables, but the instances themselves. For example, x, and then we've created 2 lists based on 2 variables. The variables are x and y. Basically, they both have the same list. So we've got the square brackets and then 1, 2, 3. So normally, if we were assessing that they were equal, if they were equal or not, if that is true or false, we would say x equal y. It will tell us yes, that is true. But then there's another option here. It says print x is y. And it's saying that it's going to print false. The is operator does not match the values of the variables, in this case 1, 2, 3, but the instances themselves. Probably, I actually don't know. Let's run it. Yeah, true, false. So I'll ask Aria. Can you explain this to me? Just copy this again. So I don't understand why x is y is printing out false. In Python, okay, we do know this, the equals operator compares the values of the variables, while the is operator compares the instances themselves. Here's an explanation using your example. X equals 1, 2, 3 creates a list instance and assigns it to the variable x. Y equals 1, 2, 3 creates a new list instance, 1, 2, 3, even though it has the same values as x, and assigns it to the variable y. When you compare x equals y, it checks whether the values of x and y are the same, which they are. 1, 2, 3, 1, 2, 3. So the output will be true. So I think what it means when it talks about the instance is where the x and y are the same. On the other hand, when you use x as y, it checks whether x and y are the same instance in memory. Since x and y are two different instances of the list 1, 2, 3, print x as y will output false. So in summary, equals equals checks for equality of values, and is checks for equality of instances, whether they point to the same memory location. I still don't quite understand what an instance is. Is it the name of the variable? Instance in programming, especially in object-oriented languages like Python, refers to a specific occurrence of a class. Here's a simple explanation. Class. A class is like a blueprint that defines the properties and behaviors of objects. It's a template for creating objects. Instance. An instance is a realization of a class. When you create an object using a class, you are creating an instance of that class. In the context of the example you provided, x equals 1, 2, 3 creates an instance of a list class. Okay, I get that. We're creating a list with the values 1, 2, 3 and assigns it to the variable x. Y equals 1, 2, 3 creates another instance of a list class with the same values 1, 2, 3, but it's a separate instance in memory from x. So in the comparison x is y, you are checking if x and y refer to the exact same instance in memory, not just the values they hold. In this case, since x and y are two different instances of the list class, x as y evaluates to false. Let me change it here and let's just put 1 and 1. Print x as y true. So now I had a feeling because we're creating like a list, I suppose, is an object within a variable. So I just want to see a so I changed the x and y variables to 1 each. And now the output of x as y is true. Is that because they are the same variable type? Does the is operator compare to variable types? Or otherwise, in the example given, is it because a list is created, which has its own set of data and information that may contain numbers and letters? Remember we did that, strings and letters, and therefore the instance cannot match. I hope that makes sense. When you change the variables of x and y to integers, that is 1, and then compared them using the is operator, x is y, the output was true. This occurred because in Python, small integers like 1 are cached and reused, resulting in both x and y pointing to the same memory location for the value 1. The is operator doesn't compare variable types. It compares if the variables point to the same memory address. In other words, if they are the same instance. In the case of integers, small integers in particular, Python caches commonly used values like small integers and reuses them to save memory. This means when you assign the integer 1 to multiple variables, they may end up referencing the same memory location where 1 is stored. So when you do x equals 1 and y equals 1, both x and y are pointing to the same instance of the integer 1 in memory. Hence, x as y evaluates to true. In contrast with lists, each list creation generates a new instance in memory, even if the values are the same. That is why x as y would be false when x equals 1, 2, 3 and y equals 1, 2, 3. So I'm just going to emphasize that point, just repeat here, that an instance in programming, especially in object-oriented languages like Python, refers to a specific occurrence of a class. A class is like a blueprint that defines the properties and behaviors of objects. It's a template for creating objects. Instance. An instance is a realization of a class. When you create an object using a class, you are creating an instance of that class. So it looks like it all has to do with the memory in Python. We're checking whether the source, whether the information in there comes from the same source or not. So as it states here, unlike the double equals operator, the is operator does not match the values of the variables, but the instances themselves. We are going to take our short break, and then that will be about 10 minutes. Then I'll see you guys shortly and we will resume. you. Okay, let's resume. We've done our is operator. Now we will look at the not operator. Using not before a Boolean expression inverts it. Print not false will print out true. Print not false, so that what we have here in brackets, which is not false, that becomes true, equals false, it will print out false. Why? Well, the false here and the false here is a bit misleading. You would think it would print true, but remember we've inverted the false here to true. And true is not equal to false. So it just seems you stuck. Just bear with me. Okay, so it's printed out true and then false. So I would like to just clarify why we have not equals. In other words, remember we did the exclamation mark and the equal and the not operator. So let me just quickly find that. Somewhere here. Yeah, the not equals operator. Is there a difference between the not equal operator and the not operator? Because remember the not equals also inverts it. Yes, there is a difference between the not equals operator and the not operator. The not equals operator is used for inequality comparison. It checks if the values on both sides of the operator are not equal. For example, x not equals y is evaluates to true if x is not equal to y. Not operator. The not operator is a logical operator that negates a Boolean value. It reverses the logical state of the operand. Example, not x evaluates to true if x is false, and false if x is true. So, sorry, my apologies. I do think I was also confusing myself there with Java. So you can do it, you can either say if something is equal or it's not equal, okay? To use the equal, we say two equal signs. Remember, we use one equal sign to assign a value to a variable. When we use the not operator, we're inverting the Boolean value. In other words, if it's true, we want to invert it to false. They serve different purposes in Python. So one is for comparing values, that is the not equal operator, and the other for negating Boolean expressions. So we are now going to do this exercise. The exercise says change the variables in the first section so that each if statement resolves as true. So here we have number equals 10. Second number equals 10. First array equals, and then we've got the square brackets for a list, but we can see it's empty. So remember what we learned about empty square brackets, that Python will automatically interpret that as false. Our second array is our fourth variable, and in that list there are items in the list. So it's not an empty list. So if number is greater than 15, print 1. So what the exercise wants us to do is it wants us to print true. So 10 is not bigger than 15. So we have to change 10. So we can change it to 16. So that 16 is bigger than 15. Then it will be true and it will print 1. If we leave it as it is, it's going to be false and it's not going to print anything. If first array, and then it says print true. So if first array is true, it will print true. It will print 2. So at the moment it's false because it's an empty array. So let's fill it up with 1, 2, 3. Now it's no longer an empty list. So it will be true by default and it will print 2. Then it says if the length len bracket second array is equal to 2, prints 3. So length, remember length counts the characters. So in this case, we have 3 characters in our second array. So we need to delete one of the characters. So I'm going to delete 3. Now it will be true, so it should print 3. Now it's saying if the length of the first array plus the length of the second array equals 5, print 4. So we've changed the length of our second array to 2. And the length of our first array is 3. We've got 3 characters here, 1, 2, 3. So 3 plus 2, it should be true, and so it will print 4. If first array and first array, square brackets 0, is equal to 1, print 5. So if you joined us in our previous live, remember what it's doing here, where it says first array, square bracket 0, it's pointing to the index in the first array. So with our indexes, we always start counting from 0. Okay, we don't count by 1. So at the moment, on our index of 0, so we've got 0, and index 1 would be 2, index 3 would be 3. If I change this to 5, just for the sake of it, index 3 would be 5. But they want the index 0 on the first array to be 1. It says here equals 1. So that is correct. It is 1. They also want first array to be true. First array will be true because it's not an empty list. An empty list by default is false. In this case, it's not empty, so it's true. So it should print 5. If not second number, print 6. So second number, let's just see here, is 10. It's not 0 because 0 by default would be false. So at the moment, second number is true if false, print 6. But they want each statement to be true. So what we need to do is we need to make the second number 0. By making the second number 0, remember Python will automatically interpret that as false. And here by using the not operator, we are reverting it to true. So it will print 6. So let's see if we got this right. Yep. Good work. Okay. We are now moving on to loops. Actually, I think we should do a revision or a recap. So I will share my screen here while we wait for it to load. So we are going to conditions. So remember, when we speak of condition, we are talking about certain requirements being met. And the way we do this is through something called Boolean logic. And what this means essentially is something can either be true or false. And depending on the outcome that we get here, which is ultimately boils down to what you've specified in your code. For example, if it's true, you want to print something. If it's false, maybe you want to pass, and so on. So depending what your outcome is here, you then specify what needs to happen next. I'm sorry, it's just taking a while to load. So we learned about, we know up until now we've been assigning values to variables using one equal sign. We now have a bit more exposure to the two equal signs, which is basically when we compare two variables. And remember, in this case, it must be explicitly true. For example, 2 is the same as 2 is explicitly true, or 3 smaller than 5 is explicitly true. But we can also use the not equals operator, if I'm calling it that correctly. Yeah, not equals operator, which we can also use within Boolean logic. For example, if x does not equal y, then print or do whatever needs to be done. So if x is 5 and y is 3, then it's going to tell it's obviously not equal, it's true, and then whatever needs to happen will happen. We learned about all the different operators. So I'm going to list them here. All the different operators that we use when applying Boolean logic. Okay, the first one we learned about is and or. What and requires is that you will have two conditions, right? And they both have to be true in order for the next thing to happen. With regard to or, you will also have two different conditions, but only one of them needs to be true. This one or that one for something to happen here. We have the in operator. So we use the in operator to check if an object exists within a container like a list. So we had a variable like name where it was John, for example, and then we said if name, sorry, in, and then whatever, let's say our list was assigned Y, then it would be true or false. Remember, yeah. So you could create your list here by using square brackets, but remember what I said about predefining variables. So that you can always go back and easily change and find your variables without having to change the rest of the code. We learned about the structure of if and else statements. So we use conditions in this context. We have if, elif, which basically stands for else if, and then we have else. So you will start your condition with the if statement. If x, y, z true, then do this. If it's not true, it will go to this line of code if there are more conditions, but if there aren't any more, you would say else. In other words, if is not true, it will do this. If you have more conditions though, you name them here, and only if all of these here are not true, then else will execute. Then I'm just checking here that we are covering everything. We also learned that in certain cases, Python will automatically evaluate a variable as false. We need to remember those things. That was very important for our exercise. Otherwise, we would have gotten it wrong. So, for example, a 0 is considered false. An empty string is considered false. Sorry, an empty list. An empty string is also considered false. And then, of course, any Boolean that returns a false value is by its nature false. We also learned, carrying on with our list of operators here, we learned about is. And is looks at, it doesn't compare. For example, if we say x is y, it's not going to compare the values of these variables. It's going to look at the instances. That has something to do with memory and where it's stored, whether it's in the same place, insofar as I can understand it. I don't feel the need to go into greater depth for our purposes on this channel on the storage of that memory. And then lastly, we looked at the not operator. Now, the not operator basically inverts a Boolean. So where something would otherwise be true, you can make it false by using the not operator. So we can now move on to our next exercise, which is loops. Hopefully it's not going to take too long. I find it just helps sometimes just to reload the whole website. So we are on loops. Not bad, guys, not bad at all. Okay, there are two types of loops in Python, for and while. The for loop. For loops iterate over a given sequence. Here's an example. So just before we go into the example, with loops, we're looking at basically the word says it, repeating something. So here we have a variable called prom. And in that variable, we've created a list, 2, 3, 5, and 7. For prom in primes, print prom. For prom in primes, print prom. So it's printed 2, 3, 5, 7 for prime in primes. Just want to check something here. So in, it is similar to our previous, not exercise, but our previous chapter where we looked for John in, and then John, then there was a list created. I'm curious to know how it knows what prime is. How does Python know that prime in this case refers to prime numbers? It is not defined. Prime is not defined. Also, how is this a good example of a loop? Oh, sorry, I forgot to paste. Pause. Let me just copy and then paste this example. Let's see what Aria says. Any data. In Python, the variable name prime in the loop you provided does not have any specific meaning associated with prime numbers unless specifically defined elsewhere in the code. In the context of the loop you shared, 1. Variable prime. The variable prime is simply a name chosen by the programmer to represent each element in the list of primes as the loop iterates through them one by one. It could have been named differently without affecting the functionality of the loop. Okay. So just explain here, because here it said for prime. Before in our previous example, it actually specified for John in and then the list, right? But now it's just said prime, and I'm wondering, but where does prime come from? How does Python know that we're looking for prime numbers? According to Aria, it looks like it's just been inputted by the, I don't know, the developer of the website. Example of the loop. The loop you provided is a good example of a loop in Python that iterates over a list of prime numbers. Here's how the loop works. It starts by taking the first element of the list primes, which is 2, and assigns it to the variable prime. Then it executes the block of code inside the loop, which in this case is just printing the value of prime. After printing the value, the loop moves to the next elements in the list and repeats the process until all elements in the list are processed. In summary, the variable prime in this loop is arbitrary and doesn't inherently relate to prime numbers unless explicitly defined. The loop efficiently iterates through the list of prime numbers 2, 3, 5, 7 and prints each prime number in the list, demonstrating a simple and effective use of a loop in Python. I think the best way I can explain this to you is we can say print primes. You're going to see that it's going to print all in one line of code. Do you see here? 2, 3, 5, 7. Underneath that is where the loop runs. So basically, what I've gathered from the explanation, because you can see the letters are underneath each other, the numbers, sorry. So for prime in primes, print prime. Primes in this case referring to this list here. So it starts at element 1, it prints it. The loop is the fact that it goes back to the list. Now it goes to the next position, which is 3. It prints 3. Then it goes back and it keeps on doing that till it gets to the end of the list. For loops can iterate over a sequence of numbers using the range and xrange functions. The difference between range and xrange is that the range function returns a new list with numbers of that specified range, whereas xrange returns an iterator, which is more efficient. Python 3 uses the range function, which acts like xrange. Note that the range function is zero-based. So I assume what that means is like indexing, we don't start counting the elements at 1. So if we were indexing this list, the index starts at 0. Then the index here is 1, then 2, then 3. So we could say print primes and then in square brackets, let's say print index 3. It should print 0, 1, 2, 3. It should print 7. So in your mind, you think it would print 5, but it doesn't because it starts from the index 0. So let's just have a look here at the range. So the comment here is that this for loop prints out the numbers 0, 1, 2, 3, and 4. For x in range 5, print x. So basically it's going to start at 0. And because it starts at 0, it's only going to go up to 4. On the second example, it's saying for x in range 3, 6. So it will print out 3, 4, 5. For x in range 3, 8, 2, it will print out 3, 5, 7. In range, it will print out 3, then 5, then 7. So I don't understand that one. But let's run the code. So it starts with 0, 1, 2, 3, 4. Then for the second example, it's going to print 3, 4, 5. Notice in these two examples, when you set the range, for example, here we set the range to 5 and here we set the range to 6. So it didn't print 5 and it didn't print 6. So there's the range function is 0 base. So just remember that. And then, so it was 3, 4, 5, and then it printed 3, 5, 7. So I'm just going to ask for an explanation on that. I don't understand how in this example it will print out 3, 5, and 7. It will print out 3, 5, and 7. In Python, the range function is used to generate a sequence of numbers. A sequence of numbers based on the specified range. When used in a for loop, it can iterate over the sequence of numbers. Here's an explanation of how the example you provided will print out 3, 5, and 7. Given the list of primes 2, 3, 5, 7, if you want to print out values starting from the second element, so from 3 onwards, you can achieve this using the range function. Here's how you can modify the provided code to achieve this. I don't feel like this is a simple explanation at all. No. Let's ask ChatGPT. It wasn't working just now, but I'm going to refresh it. Is it properly loaded? Doesn't look like it. There we go. I actually feel like ChatGPT is very good at explaining coding in general. Let's go. Okay. The range function in Python is used to generate a sequence of numbers. When you use range, you typically specify 3 parameters: the start, stop, and step values. Here's a breakdown of how it works. Remember when we used slicing, we also had a start, stop, and step. So these are things they failed to specify on the website, python.org. But for us on this channel, we don't let things like that slip by. If there's something we don't understand, we ask. So within a range, there's 3 parameters: a start, a stop, and a step. And basically, in the previous 2 examples, because we didn't specify, it was like this when we did slicing of strings. Because we didn't specify in this range any other values, it looks like it starts from the left. And it will, no, you know what, it's probably different starting. Start is the starting value of the sequence, which is inclusive. Stop is the ending value, and it's exclusive. So remember, we noted that in these two examples, these two simple examples, we noticed that we're telling it to stop at 5. So remember, if we use our index counting, 0, 1, 2, 3, 4, we're telling it to stop at 5, meaning it won't print 5. It's exclusive. And the same here. It won't print 6. Step is the difference between each number in the sequence. And what we picked up when we were doing slicing was it's not necessarily left to right thinking. So in this case where we have three, what would you call it? 3 parameters. We look at where we start, we look at our steps, and then we tell it when to stop. So now I can see it starts at 3. Remember, it's inclusive. We add 2 steps to 3. That would be 5. Remember, our target is to stop at 8, but that excludes 8. So the answer, if we add 2, can't be 8. So if we add 2, we get 7. So it's great. We're still in the safe zone. But now if we want to add another 2, we're going to get to 9. And that's going to be a problem because we've told it to stop at 8. If we say here, for example, we want it to stop at 7, it will only print out 3 and 5. You see it, 3 and 5. Guys, I'm aiming to take breaks just to, like I say, I know it's a lot. And I'm aiming to take breaks every 30 to 40 minutes. It is 10 minutes, and I will put timestamps in just to make it easier for you as well. So I'll see you in about 10 minutes. welcome back. Let's just go here. So we identified that this is our start, this is our step, and this is where we stop. So the moment I put in 7, it couldn't print the 7 because the stop is exclusive. It printed the 3 because the start is inclusive, and it printed the 5 because we're moving up in steps of 2, so 3 plus 2 is 5. So that is how we can use a range within a for loop. Then we have a while loop. While loops repeat as long as a certain Boolean condition is met. For example, count, and we've assigned it a value of 0. Keep in mind that 0 is false by default, but the question here, or the loop, is that while count is smaller than 5, print count. Count plus minus 1. This is the same as count equals count. This is the same as count equals count plus 1. So when we use plus equals 1, it will keep adding 1. And it will keep doing that for as long as the count number is smaller than 5. Smaller than, but remember, not equal to 5. So what we should get is it will start at 0, and then it will print out 0, 1, 2, 3, 4. If we change this to smaller than equal, it should print out 0, 1, 2, 3, 4, 5. You see they printed the 5. Let's just revert it back to the way that it was. Again, I just want to emphasize, see here it's printed up to 4, that when we're working with loops, it prints count and then it runs the loop. Because for every time that count is smaller than 5, the Boolean value is true. So remember what they say here, while loops repeat as long as a certain Boolean condition is met. And the Boolean condition is that count must be smaller than 5. And it will keep going and going and going until this condition is met. That's the while loop. Then we have the break and continue statements. Break is used to exit a for loop or a while loop, whereas continue is used to skip the current block and return to the for or while statement. So count equals 0. While true, print count. And then we're going to keep adding 1. So we use plus equal to add 1. If count is bigger than or equal to 5, then break. So while true, let's just run this. So it prints out 0, 1, 2, 3, 4. If count is bigger than or, it says bigger than or equal to 5, so why doesn't it print 5? So let's ask ChatGPT. It's saying we must break when it gets to 5. I don't understand why this will only print up to 4 if the statement is bigger than equal to 5. But it also says, remember, break is used to stop. Yeah, let's see. I forgot to add the example. I think I need to refresh my ChatGPT again. You can look at the next one so long. So for x in range 10, in other words, it will go 0 up to 9. We want to check if x is even. So if x, that's the modulo operator, divided by 2 equals 0, then continue, print x. And it will print out only odd numbers, 1, 3, 5, 7, and 9. Remember, it will stop at 10. But now I'm a little bit puzzled. So this part, to explain it to you, remember that the modulo operator determines if there's a remainder. So any even number that's divided by 2 will not have a remainder. In other words, the remainder will be 0. So that's how we check if x is an even number. And they want us to print x in the range of 10, but it looks like they don't want to print the even numbers. So continue is used to skip, in this case, the even numbers. So that actually makes sense. So it will print 1, 3, 5, 7, and 9. Let's go back here and so that one actually makes more sense. I don't understand because I'm not having buffering issues yet. My internet just seems to be lagging on the browser side. What I also wanted to find out was with the range, how a range is different to slicing a string. I'm sure there must be a difference because there's 2 different operators for that. So it will be good for us to know. I'm going to have to use Aria. It's just I didn't like Aria's explanation. So my question was, I don't understand why this will, let me switch to the screen so you can see. So we're looking at this example over here. And I'm saying, I don't understand why this will only print up to 4 if the statement is greater than equal 5. So Aria says that in the code snippet you provided, the loop will print numbers starting from 0 and incrementing by 1 each time. So it starts at 0, the plus equals keeps adding the 1. The loop will continue until the count reaches 5, at which point it will break out of the loop. Here's how the code works step by step. So we initialize the variable count to 0. So that's what we did here, count equals 0. Then we enter an infinite loop. So while is the infinite loop. We print the current value of count. While true, print count. Then we say count plus equal 1. Increment the value of the count by 1. Check if the value of count is greater than or equal to 5. If the condition is met, count is 5 or greater, the loop will break and the program will stop executing. Therefore, the loop will print numbers 0 to 4, because when count equals 5, the condition if count greater than equal 5 becomes true, and the break statement is executed, causing the loop to terminate before printing 5. Okay, that was actually quite obvious. So the moment count reached the value 5, the loop stops. Okay, then I just wanted to point out on this one, for x in range 10, if x is an even number, continue, it means that we skip that block and we print x. With these while loops and these break and continues, I think we just gotta be careful when we define our ranges and all of the things like that, that we don't create literally an infinite loop. So I'm quite happy that I understand all of this. Are there any questions? Doesn't look like it. Did have one question, and that's in this statement for x in range 10. We haven't set the counter. We haven't initialized the variable to 0. So in this example, x was not initialized to 0. Like here we define count equals 0, but here we haven't done that. Is that why? Is that why it will start printing at 1? I think it's also because you can't maybe divide by 0. And it requires working out a remainder. So Aria says in the code snippet you provided, if the variable x is not initialized to a specific value before the loop begins, its initial value will depend on the context in which the code is executed. When a variable is used without being explicitly initialized in many programming languages like Python, its initial value is considered to be undefined, and it can contain any value that happened to be in that memory location at that time. Therefore, if the variable x is not explicitly initialized to 0 before the loop starts, its initial value will be unpredictable. In some cases, it may start with 0, while in others it may contain a different value. This behavior is generally considered undesirable, as it can lead to unexpected results in the program. So it's always a good idea, like they say here, to initialize it, but it's also a good idea to always define your variables. Because that's effectively what we did here. We defined count as 0. Can we use else clause for loops? Unlike languages like C, CPP, we can use else for loops. When the loop condition of for or while statement fails, then code part in else is executed. If a break statement is executed inside the for loop, then the else part is skipped. Okay. Note that the else part is executed even if there is a continue statement. I think we would only understand that by looking at a practical example. So here we have count, which is initialized to 0. We're saying while, which is an infinite loop, count is smaller than 5, print count. And we're saying count plus equal 1. Else, now let's see, when the loop condition, in other words, when this fails, then the code in else is printed. Else, print count value reached, and then the percentage D is for the decimal, and then here we create our loophole. So it will basically tell us where it reaches 5, and that's why it's not running anymore. So it will print out 0 plus 1, so 0, 1, 2, 3, 4, and then it will print the statement count value reached 5. Let's look at the second example. For I in range 1, 10. So it looks like we are starting at 1 and we're stopping at 10. And if we're stopping at 10, it means 10 is exclusive. So if I modulo 5 is equal to 0, break. In other words, we're going to stop the loop and we're going to print the value of I. So, in other words, does the number need to be divisible by 5? Else, print. This is, and then it will print. This is not printed because for loop is terminated because of break, but not due to fail in condition. So I'm going to have to ask for an explanation. If I divided by 5 does not return a remainder, but it's telling us it's going to print 1, 2, 3, 4. For I in range, we're going to print I, but if, oh, that's why it's stopping at 5. Once it reaches 5, right, when we divide 5 by 5, 5 goes into 5, so there will be no remainder. At that point, when it reaches 5, and remember we haven't defined the steps, so it's automatically going to go in steps of 1. Okay, so it's going to start at 1. Let's go 1, 2, 3, 4, 5. Up until 5, when we divide the I value by 5, it's going to return a remainder. Now, our if statement is once a remainder is not returned, as in the case of 5 divided by 5, which is 1, basically the loop will stop. It will print I, because remember it's a for loop, so it's going to execute till that if statement happens. And then there's an else statement, which says this is not printed because for loop is terminated because of break, but not due to fail in condition. So let's run the code. So in our first example, we started at 1, we initialized count at 0, Then we were going to keep adding 1. And for as long, because it's an infinite loop, for as long as count was smaller than 5, it would keep on printing. It would keep on running the loop. But the moment it got to 5, it prints a string and we formatted the string, and we need to know how to do this. Count value reached, and then it inserts the count value. You see why formatting strings, if I may just diverge here briefly, formatting strings is important because this value, this count value, can change. For example, if we change this to 10, this %d will change automatically. Okay, but if you are putting your number in manually, in other words, you're trying to predict it all the time, it's not practical. All right. We can put in count value reached 5, but it's not practical because these values can change. So you need to be comfortable formatting and reading formatting, like understanding this is the loophole that will give us the count value. Then for this one, we've run our loop in the range of 1, starting at 1, and then we keep going. So it's going in steps of 1. 1, 2, 3, 4. Now it's saying our range is 1 to 10. But what this example is showing us is we can include an if or an else statement, right? And this is our if-else statement. Okay, this whole block of code here. It looks a bit confusing because of the indentation. But this is our if-else. Remember, an if statement always works with if-else. So let's read that. To understand this question, let's read it as a whole. So our range is 1 to 10. But now we've decided we're going to add a condition. Okay? So if any remainder, if I divided by 5 is whole, in other words, there is no remainder, then we're going to stop and we're going to just print I. So we're going to break, and I see it says print I. Yeah, so it prints I. Okay, all these 1, 2, 3, 4. If this condition was never met, so remember an if statement can be true or false. Only when the if statement is not true will the else statement print. In this case, it was possible at a point for if to become true. In other words, when the counter reached 5, if became true. So it did not become necessary to print the else statement. Okay, so it's if else. Don't confuse if else with the loop. The else is only there if the if condition is not met. So I'm wondering if there's a way we can test this so it prints the else statement. Let me just see it. So we want, how can we do this? If we set our range to 4, so 1, 4. In other words, we're not going to go up to 5. We're always going to have a remainder, meaning this will be false. It will never be able to be true because we've limited our range to 1 and 4. It should print the else statement. Remember, the 4 is exclusive. So it should print 1, 2, 3. So it prints 1, 2, 3, and then it says this is not printed because for loop is terminated because of break, but not due to fail in condition. That's just a fancy way of explaining what I've just explained to you. Okay. There was something else I wanted to mention. Keep in mind, also, like with these things, like I said, you don't want a loop running forever. Okay, you don't want an infinite loop. I don't know if you can actually break your computer doing that. Okay, so let's move on to our exercise and let's test our knowledge. This looks intimidating. Loop through and print out all the even numbers from the numbers list in the same order they are received. Don't print any numbers that come after 237 in the sequence. So we haven't actually been writing the code. We've more or less just been reading it and running it. But we've identified how to work out the even numbers. In other words, it must, when we use, you know what, no, that's going to confuse it. When we use the modular operator, so the percentage, it must return 0. Then we know, sorry, modulo 2, it must return 0. Then we know it's an even number. So let's just see how we put that in the code. And then we don't want to print any numbers that come after 237. So now I feel like it's a choice between while and for. So let's look quickly at the difference here. For loops iterate over a given sequence. So for in primes, print prime. While loops repeat as long as a certain condition, Boolean condition, is met. So we've got our example here. It looks like we're going to use the for. For loops can iterate over a sequence of numbers using range. I think we can specify our range, right, so that it stops at 230. Don't print any numbers that come after 237. So any numbers after 237. So we're going to create a range for number in numbers. I don't think we're going to use range. This is correct. They're sort of giving us a hint for number in numbers. And they're telling us we need to use the for. 4. And we don't want to break, we want to continue. If we break the loop, it will stop the loop from running completely. We want to continue over the even numbers. So we want to say if, I just need to refer to the above because I'm not used to Python syntax. If number percentage, which is the modulo operator 2, is equal to 0, we want to continue, meaning continue means that we skip the even numbers. At the same time, we can't stop there. We still need to print number. Does number need to be in brackets? Print, yeah, it does. Print number. So the question is loop through and print out all even numbers. So we actually don't want to, we don't want to skip the even numbers. So we want a remainder. So I suppose we can use the not equal. Not equal 0. Let's submit it and see if it prints all the odd numbers. Even numbers, sorry. So you can see here, it skipped 951. It's done 402, 984, 651 is odd. It's done 360, so it looks like it's worked. Now the last bit of the question, so we've managed to print all the even numbers in the same order they are received. Now they say don't print any numbers that come after 237. So I'm going to use and. So I'm going to say if number is going to be and or. So we I'm thinking because there's two conditions. The one condition is that we can't print even numbers. I've established that much. The other condition is that we need to stop. We need to break at 237. So at 237, we need to break. Because if I say and number is equal to 237, it's not going to work because I'm saying continue. So I'm giving it competing messages. Let's look at our various tools here. We've got the for loop, we've got the while loop, It's not the while loop. I can actually see why, because the plus minus 1, the plus 1 wouldn't have worked because we've got a defined list. That's what the for loop does, is it iterates over a given sequence of numbers. Then we've got break and continue. Break is used to exit a for loop or while loop. Count equals 0. While true, print count. Count plus 1. If counts, while true, count equals 0. While true, print count. It's not else. It's definitely not else. For number in numbers. If this is why coding is challenging, but I like it. I'm happy we got the odd numbers out of the picture. You know what we can do? We can say if number what if we said print number, and then we can say while number in while number is don't print numbers that come after 237. While number is smaller than 238, break. So don't forget our colon. Then we want to break. Let's see if that works. Your number object is not correct. You should use an if statement and a break statement to accomplish your goal. Because the way I understand this is we've created 2 loops, and I want it to be in 1 loop, not 2. So for number in numbers. For number in numbers, if and I think I get it. If number is an odd number, we actually want to print, don't print any, we need to print the even numbers. So I got a bit mixed up here. We want the remainder to be 0. So we want to print the even numbers and the number, as long as the number is smaller than 238, it will continue do we need the continue? So I'll just say print number for now, and then remember if else. So else will be break. So it looks like we go back. Else, break. I just want to check here. Else, break here. So I need to put in the colon. Still getting used to the syntax. Else break. So these two conditions must be true. The number must be divisible by 2. In other words, it must be an even number. And the number must be smaller than 238 for it to print number. Else, if none of these are true, it must break. Continue. I think we need to continue. Because if we just say print number, every time we get to an odd number, it's going to stop the code. Your code could not be passed due to an error in indentation. Ugh. I think else goes all the way to the back here. Else. Submit. Define an object number using the code from the tutorial to print just the desired numbers. Syntax area break outside loop. So it's saying we need to define the object number using the code from the tutorial to print just the desired numbers. Oh, we don't want it to continue because continue means it will skip the even numbers. Let's just try it without continue. Define an object number using the code from the tutorial to print just the desired numbers. So we want to print the number because we don't want to print all the numbers, and that's what it's doing at the moment. Print looks like we need to use break. No, break is at the end. That's why I had it as not equals, because we had to skip it in order to print the number. What if I use or instead of and? We'll say continue, print number. We get the solution. I think so. I don't want to bore you guys with my struggles. Ultimately, what matters is that we understand it. For number in numbers, if number is equal to 237, break. If number and then modulo 2 is equal to 1, continue and print number. So it looks like, from my understanding, in your for statement, you can have multiple if blocks. Let's ask ChatGPT or maybe Aria. Am I understanding correctly that in a Python for statement, there can be multiple if blocks? In other words, if doesn't have to be followed with else or aleph, and the multiple if blocks become inclusive, if that makes sense. Because I was worried that about the and, because there were two conditions that had to be met. Yes, you are correct. Python can have multiple if blocks within a for loop without needing to use else or aleph. Each if block will be checked, independently, and if the condition is met, the corresponding block of code will be executed. In your example code snippet, for number in numbers, okay, we know that, the loop iterates over each number in the numbers collection. If the number is equal to 237, the break statement will exit the loop. If the number is odd, the continue statement will skip the remaining code in the loop and move to the next iteration. If neither of the above conditions is met, it will print the number. So they both had to be false to be able to print the even numbers. So in other words, once it reached 237, or for if number is equal, that means it would be true, it would break. So I just want to say my concern was that after that Python, because I didn't know you could do this in Python, that Python would run the first if block until it got to 237 and then not print the even numbers as desired. Okay, so this explains it nicely. Python will indeed stop the loop when it encounters the number 237 due to the break statement. However, the subsequent if blocks will only be checked if the break condition is not met. So if the number 237 is in the numbers collection, the loop will terminate at that point without printing any further numbers. So that's actually, part of our basics. So for as long as this was false, remember it then runs to the next if statement and then it will print. It will skip the odd number, it will print the even number, and then it will repeat because it's a for loop. So just to explain it one more time. For number in numbers, if number is equal to 237, it means stop the code. That was our desired effect, right? We didn't want to print any numbers after 237. But we know that for a range of the numbers here, we can go, there are numbers here within What happens if I submit this code? Don't print any numbers that come after 237. 237? Oh, it's talking about the numbers not in a linear sense. Anyway, so it won't print wherever the number 237 is here. Just find it, 237. It shouldn't print anything after here. That was the desired effect. So for as long as this was false, then what happened is that the next if statement is run. Well, and remember we're looking for, ultimately we want to print the numbers. So as long as the number is odd, it means skip that number and then print the next number and then repeat and keep repeating till one of these becomes true. And the first one to come true would obviously be 237. That's the result that we want so that it stops. So this has been a 2.5-hour stream. I think we will stop here. These sessions are getting longer as we go along because, yeah, it does get harder and more complicated. There was one more thing I wanted to find out, which what is the difference between a range and splitting a string? What is the difference between range and splitting a string, both of which can have, was it splitting? Where did we have the stop, the start step, start, stop step? Both of which have a, both of which can have a start, a stop, and a step parameter. That's the last thing I want to do for this video. The range function and splitting a string are two different concepts in Python, although they may share similarities in terms of having start, stop, and step parameters. The range function in Python is used to generate a sequence of numbers. It is commonly used in for loops to iterate over a sequence of numbers. Splitting a string in Python involves dividing a string into a list of substrings based on a delimiter. The split method is used for this purpose. In summary, the key differences between range and splitting a string are: range generates a sequence of numbers based on start, stop, and step parameters, while splitting a string divides a string into substrings based on a delimiter. Range is used for numerical sequences, while splitting a string is used for text manipulation. The split method for strings does not have start, stop, and step parameters. It solely relies on the delimiter to split the string. So splitting applies to strings and range applies to numbers. Yes, that's correct. You see, yeah, it does. I don't know. Ari is calling it a delimiter, but it does have a start, effectively a start. And this is according to the learnpython.org website. It does have a start, a stop, and even a step feature. Yeah. Also, just keep in mind that the splitter, it's actually it's called a delimiter, and we use it in square brackets by the looks of it in terms of syntax, and the range we use with round brackets. That's it for today, guys. I will catch you again tomorrow. I hope you enjoyed the episode. The best way to do this is to try and practice yourself. I hope you coding along with me, and shout out if there's any questions. Thank you so much for watching. Goodbye.